Good afternoon, and welcome to this week's edition of the Friday afternoon Pentair Water Break. Thank you for joining us. Um, Today's topic is going to be solutions to colored water issues. Now, this is one of those discussions that um, has a rather large, sorry about that, caveat to it. This is one of those instances where we really need to understand what's causing the color to understand the treatment train involved. So, with that being said, we're going to crack open this topic. If you have any questions during the presentation, feel free to throw them into the chat or hang on till we're done and you can ask questions then as well. So, let's go ahead and get started here. So, solutions to color water issues. Now, it all starts like we talked with last time about the causes of the color in our water. Dissolved ions, both anion and cation, negative and positive, may contribute to color in the water depending on concentration level. And the other source we typically see in potable water sources, both well and municipal, is going to be turbidity. Turbidity can provide color from iron particulate rust or just physical debris in the water, ranging in particle sizes from the visible to the submicron to a point where standard filtration products won't remove them. So understanding what we're dealing with is critical to addressing the problem. And sometimes these issues are multiple. You may have a turbidity issue layered on top of an anion or cation color circumstance as well. So understanding what we're dealing with to start with is a critical place to be. But for turbidity issues related to color, you can start off with some rather inexpensive tools here, like the R series, which is a polyester media, which is going to be able to handle some chemical environment if you were doing oxidation in front of this. Let's say this is going to give you that large particulate removal in a robust cartridge that's going to withstand some chemical injections and things like that. But if you're just looking for straight particulate removal on a well source, more so than a municipal, because you're going to have sanitizers there, the ECP is a cellulose polyester blend available down to 1 micron. The nice thing about the R series polyester, you can reuse these and sanitize them and reuse them. We don't recommend that, but there are applications where that may make sense for someone using a polyester cartridge handling their dirt load, especially if it's going to a non-potable application. Other sediment filters, depth filters are really a great place to start when it comes to colored issues from turbidity. The PolyDepth series is a cartridge that can handle up to 175 degrees in temperature. So if you're having issues that are temperature related to turbidity and particulate, this can handle that cartridge. These go down to as low as 1 micron. These are going to fit in those 2.5-inch housings. And fit into places where larger filters won't go. But these are depth filters. They're going to hold a tremendous amount of dirt, and these are going to change color in a clear housing so people can see the dirt load accumulate. But they're going to hold dirt, and on pulsed intermittent flow, they're going to reorganize that dirt a little bit and allow for higher flow rates. But my favorite cartridge for a general turbidity solution is the DGD series. Why? This product allows for a tremendous amount of dirt holding, so longer run times between changes on the same water source compared to other products, but it also acts as sort of an indicator. This cartridge goes from looser to tighter as we go towards the core. And if you look at the DGD listings, 2501, 50, 10, 5005, and 7505. Those are the micron ratings from outside decor. So 25 to 1 micron, 50 to 10 microns, 75 to 5. And what's wonderful about this makes a great introductory sediment cartridge. And the next time you see it, what will happen is the dirt load will stratify out inside the cartridge, kind of like tree rings in a tree, a log being cut. You'll be able to see where the dirt stops. And let's take the 2501. If it stops about halfway through that cartridge, I know that dirt load is going to be 10 micron and larger. I may even swap out that cartridge. But it will also show you if you have dirt load across the entire spectrum of that cartridge. And if the core is dirty, you will see things that are getting through that are below that size. So it's a great way to evaluate dirt load without doing any testing and starting out. This in front of a Fiberdyne cartridge in the 4x20" makes a great introductory package for those dealing with well water dirt load issues or even municipal dirt load issues. Wonderful for that applications. And we actually specify these throughout the commercial world as well for these characteristics. These hold a tremendous amount of dirt and are very, very versatile. They're designed for chemical resistance. They'll handle some of those more difficult waters that you may come across as well. Now, there are a few circumstances in turbidity issues that those measurements that we do, that we discussed last time may come into play. When we form iron particulate or oxidize iron at high pHs, we may create colloidal particulate. Colloidal particulate is submicron, smaller than 1 micron, and can be so small that it doesn't drop out of water easily. It's not heavy enough. It just sort of floats like dust in the air, never wanting to settle out. And you may have to go to something like a UF filter. We do offer these products in other business groups for industrial appliances applications, but understand that these technologies are out there and that particle size may require something like this. In well water environments, we see that with iron particulate formed in wells. Some well strata may be in clays where that clay is super fine and sticky, and you need something that can wash itself to survive in that environment and not create nuisance following and those sorts of issues. And sometimes debris, even as super fine sand, may come out of a well where you may need something like ultrafiltration to handle that. So please be aware that those options are out there. And many of these products will have a biological application to them as well, where they're reducing bacteria as well as potentially virus, followed up with a UV, and you've got a pretty complete dirt load and protective system there. Just be aware that this may be the solution to your problem if you're dealing with submicron stuff. And also be aware, if you're doing iron removal, understand that pH is above 8.5 are going to cause that iron oxidation that you're doing to form very, very fine particulate. So you may be creating another problem for yourself while solving one. So remember, how we do these things impacts the next step. Now, ionic color issues, this is where ion exchange is going to shine in resolving these issues. Most of the time when we see ionic color issues, it's due to aggressive waters dissolving things either in the well strata itself or in the municipal system. So understand pH, low hardness, super soft waters can contribute to ionic coloring. And just as a note here, if you're experiencing blue staining in your water or blue color in your water, copper, that normally indicates copper. Copper is not naturally occurring in standard well waters and municipal waters. That's going to indicate that we have a corrosion issue. And we're probably going to want to manage that corrosion issue rather than directly treating the copper. The copper is a byproduct of another issue. Another caveat to this is short-term rental properties with water softeners. The longer you leave soft water unflushed out of a copper pipe, it's going to dissolve some of that copper. Water softening systems in copper plumbing are designed to be used, not static. So understand that if there's long durations between occupancy, short as a couple weeks, a month or so, you may see color come off the first purge of that system. And that's more of a flushing than a treatment circumstance. So softeners, traditional water softeners using cationic resins are going to remove cationic colors. Things that are related to iron in the water is very common. You may get a yellowish to brown color. You may get some brownish blackish color from manganese. If you're seeing blues and other odd bright colors, we definitely want our water analysis in those situations, because things outside the rust color spectrum aren't really common in potable water systems. And we want to understand that color first before we add solutions here. And there's lots of different valve products that you can choose to manage that cationic color process in the water. It's also going to solve your hardness issues at the same time. Multi-step processes there in one tank, right? So understand there's lots of options there, and it all starts with understanding that starting water quality. Now, we do have specialty cartridges that are designed for smaller applications that you may not need a full backwashing regenerative ion exchange system to solve. We do have the WS series of cartridges. These are water softener cartridges in standard and big blue sizes that have a range of 750 to 4,500 grain capacity. These are low volume softening applications, and these work great for small ice makers if you need them, coffee bars, food trucks as well. This may provide a portable solution to variable water qualities for those circumstances. Fish tank refills for hobbyists, those sorts of dynamics come into play here. Just remember, this is a low volume application. This may even work on humidifiers for people in their basements and things like that for softening that water if they don't have a present softener. These are FDA grade resins used in these cartridges as well. And then we also have a deionization cartridge. And if you're using the standard drinking water, our own, you follow it up with one of these, you can produce rather good quality laboratory quality water for the home hobbyist who may be a brewer or a distiller. This is perfect after an RO to get that stripped down water quality to add ingredients back to. This is great for sterilizers and office equipment in doctors' offices and physicians' offices to provide that water they need for those appliances. So you have that ability to clean up the color in those situations as well. We also have oxidative cartridge called the RFFE. This will handle low levels of iron and manganese in the water. And once again, this is a lower flow, lower volume solution to color problems. Once again, food trucks, this is great for putting on as the first step in a treatment train in those sorts of venues, because those are going to go all over the place and get all sorts of different water qualities. This followed up with a DGD and a Fiberdyne cartridge in the 3 housings. You have a very simple, portable, serviceable system for treatment for a small business. Now, there are some curveballs that happen when we deal with color. And One of the bigger headaches in well water treatment is shallow wells with tannins. Tannins will occur in deep water wells, but less likely and are usually related to a casing break or seal break where it's allowing surface water into the well. But tannins are organic acids, and one we've been talking about lately a lot is PFOAs and PFOSs. Those are organic acids. They're just fluorinated organic acids. Humic acids also occur in shallow wells. These are organic acids. That's that swampy smell when a lake turns over in the fall and the spring that you may smell. The bitterness in your glass of red wine, that's tannins. It's that oakiness that may be excessive. And then the last problematic issue that will provide color is organically bound iron. This is when you have iron and tannins in the same system, and because you have a positive ion and a negative anion, they will bind and bond together and produce something that's rather difficult to remove with either method. So understand there's some curveballs here. Now, for anion exchange for tannins and other organic acids. If you're targeting PFOAs, make sure you use a material designed for that. But if you're targeting tannins, tannin resins are available in chloride form, so you can use them or even share a brine tank with a cation softener if it has its own well system inside of that brine tank. You can use that same reservoir of salt. Pre-treatment may be required for tannin removal resins. Always check with your resin OEMs on the products they use for the information for pre-treatment, because that's going to impact your overall system design. This is the best solution for higher levels of tannins in the water. But it's also very, very good for low levels of tannins in the water as well. But those can be a little more cost effectively reduced with activated carbon, those low levels of tannins. It all depends on your water quality to start with. Make sure you're sending in water analyses to OEMs about your waters with color. That may be a challenge for you, so you can get their best input and look at different technologies so you can design the lowest cost version of a treatment train for that specific water. Now, activated carbon is best used on low levels of tannins. Why? Tannins is a large charge, as a large molecule with a charge on one end. This will remove good bits of tannin from the water at low concentrations. But if you're oxidizing your tannins before activated carbon, you're gonna need a little more catalytic version of that carbon is going to be able to handle smaller organics as well. pH modification prior may help in removal with using activated carbon for tannin removals. Remember, run the water analysis by your carbon and resin OEMs to get their input on their products for this solution, and take that information and look at what's going to be the most cost-effective solution for this water for this customer. Okay? It's very, very difficult to one size fits all for these circumstances. Now, multi-stage design for tannin removal. This is really the place where we may be dealing with dissolved iron, particulate iron, tannins in the water, and there's a lot of shallow wells in North America that may fit this bill, where you're going to deal with multiple things. Quantity of that material dissolved in the water is going to dictate what we wish to do. And sometimes we have to address what's best to produce the best result for the next piece of equipment so we can limit the pieces of equipment on site and make sure we're not overcharging a customer to get the right train on site. Low pH may assist in ion exchange effectiveness, just because our resin cleaners are acid forms. We're going to put that resin back into an acid form, drive everything off of it. And this may help in ion exchange during its normal flow through process and having an exceptionally clean bed that's willing to exchange everything off of it. Be careful with this. If you have low pH coming into the building and you're doing cation exchange softening first, you may have to do pH modification afterwards to raise that pH, to make it beneficial for the plumbing infrastructure, right? Iron above 2 parts per million in the water may require direct treatment for iron to keep that cationic resin bed from fouling over time. Make sure you understand whether or not you have actual dissolved iron versus organically bound iron in the water. And remember, when we oxidize iron, we are creating a dirt load. So make sure you evaluate that dirt load that you've created in that removal system, like an AIO, that we're getting that tank backwashed thoroughly enough at the first time you see it after a startup. Make sure that backwash is getting that tank clean. We don't leave that stuff in there. If you're dealing with pHs below 5.5, there are areas of North America that have wells with rather low pH. The upper Northeast, Maine, New Hampshire, there are areas where you'll get well waters as low as 4. I've heard of 3s of pH. That may require chemical injection to handle those situations and elevate the pH enough in order to do good treatment. pH management may cure your colored water issue via precipitation alone. That's what we're doing with AIO. So understand that balance in the water. And if you don't, get people like myself or your resin and media manufacturer experts involved to discuss your options. Take some time to learn about the process here. AIO may be applied with pH modification to remove iron and sediment down to 3 micron, depending on the media. Remember, the vast majority of pH modifications used in iron removal are there just to keep hydroxide in the water for precipitation, a pH above 7. So understand we want to keep that pH below 8.5 at the top end so we don't create colloidal particulate that goes through our system and out to the home. Anion removal may require softening, cation softening prior to anion exchange. Understand that dynamic when you select tannin medias for iron removal or for anion removal. Excuse me. Now, if you come across a well that has color, turbidity issues, iron issues, and arsenic, please reach out to your media manufacturers about their arsenic removal methods and give them a complete water analysis with that. There are lots of methods to do that. And if you're dealing with arsenic, make sure you're getting the right test kits for fixatives in those waters to get the speciation of the arsenic 3 and 5 correct, and really file some good guidance from your resin OEMs there or your mediums OEMs there. Use the least impactful on pH oxidant possible. Not all chemical oxidants will affect pH, and some of them need to be in a proper pH range to be effective. Chlorine's one of those. Too high of a pH, you're using the chlorine to balance your pH, and too low of a pH, chlorine isn't even an active oxidizer. So chemical oxidizer may solve multiple issues at once, but it's going to require a contact tank to do that. Oxidation may break down those tannins in the water and break down some of that organic turbidity, but you're going to need activated carbon to follow up afterwards to clean that up. It may even break down that color where you don't even see it anymore and turn it into more dissolved um, materials at that point in time. Um, and this may require more sophisticated controls to manage. AIQ controls, we do have relays available to control injector pumps. So we do have synergized equipment to do so. Inline mixing versus a contact tank, depending upon your situation, both require dirt load management. Tannins may require activated carbon, cation, and anion softening. So it may be a three-step process. Always consult your media OEMs for best practice on your waters. Get multiple quotes for the best design for this water quality based on the technologies you select. So water analysis is the starting point here. Knowledge of the water is paramount to success. If I don't know what I have to treat, I'm guessing. And when we guess, it gets expensive. It also reveals the relationships in the water, that if I change this, what happens to the water? What's going into the water? I want to make sure I understand the materials of the equipment I'm sending that water to, so I'm not necessarily creating a potential corrosion environment, especially with anion softening. We're putting chlorides in the water. The water determines the best solution. That's really what this comes down to. We need to understand where the customer wants that water and what we're starting with. We can find the solution to put in between. That's really the choice. Where does that customer want that water to be? And can we get there the most cost-effective package? Explore new medias to find the best solution. Be curious about your offerings there.